This is the Amp Hour Podcast, recorded September 30th, 2013. Episode 165, with guest Henry Ott, Forced FCC Filtering.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Henry Ott of Henry Ott Consultants.
And you nailed that intro, Henry. Well done.
Yeah.
Most of our guests goof it up in some way. Thank you very much for coming on our show.
One of the legendary consultants of the world of EMC and noise and everything else.
I don't know about that, but I'm there. I've been around a while.
Yeah.
So can you actually tell us where you're from and what you're doing these days, and then we'll go back into your deep, dark, mysterious past.
Okay, well, I'm located in New Jersey, but my business is pretty much all over the country, mostly U.S. and a little bit in Canada. I limit myself. I kind of don't go overseas anymore. No sense in traveling all those distances. So I kind of limit myself to the U.S. and Canada, as I say. And, we do a lot of EMC training and consulting. I do probably the biggest thing I do is training classes for individual companies at their location. And then about twice a year, we try and do a public EMC class available to anybody. Usually one on the East Coast, one on the West Coast. As a matter of fact, just last week we had one in Detroit. And the rest of my time I spend consulting. And that kind of keeps me out of trouble and keeps me busy.
Yeah. You mentioned Detroit there. We've talked about a lot of the demise of the industry on this show. How is the Detroit electronics industry going? Well, out of curiosity.
That's a good point. We scheduled it in Detroit, and shortly before they announced the city went bankrupt. Well, actually, it wasn't Detroit. But yeah, good timing, right? It wasn't Detroit. Right. It's outside of Detroit, Dearborn. Okay, yeah. But I think the auto industry is coming back there pretty much in that area, in the Michigan area. Let's put it that way. And when we do the public classes, we maybe get a third of the people from local areas, and the rest is from all over the country.
Oh, right. They all fly in.
Yeah, as a matter of fact, we had one fella from Sweden even.
Oh, wow.
Quite often, we had two from Canada, from Alberta, the west coast of Canada.
Wow.
So, quite often we have two or three. We had about 50 people, two or three, probably maybe three or four quite often from outside the U.S. And so it's not just local, but I think the things are a lot better in that area with the auto industry coming back. Probably 2 years ago, things were not very good.
Right. And is it just you in this consultancy, or do you have a small group of people?
Right at the moment, it's myself. I have an assistant that kind of runs the office and takes care of things for me when I'm gone, answering the phone, making arrangements, and doing things. Back a few years, I had another engineer working with me on it, too. He worked for me for about 5 years on it. But he got tired of traveling, and that makes it difficult in this business.
Yeah, definitely.
I can imagine.
What does a public course kind of entail? Like, so you said it's a week long, but is it just kind of running through the gamut of here's EMC, here's how you design around it, you prepare for it, that kind of thing, or what does a course like that involve?
Okay, it's actually a 3-day class. I said it's a week, but I travel out the day before, come back the day after. It's a week of my time.
Right. Yeah, right, of course.
It's a 3-day class. It's pretty much a general overview of EMC. We cover such things as cabling, grounding, shielding, digital layout and grounding, high-speed digital decoupling, mixed signal PCB layout, common mode, differential mode emission, common mode filtering, conducted emission, RF and transient immunity. So that's so we cover pretty much a gamut of different subjects, trying to make the the broadest appeal. I also do a lot in-plant of one-day classes where we just spend all day on one subject. Like we might talk about shielding all day or mixed signal layout all day, going into more depth. But usually the public courses I do as a general class, general course with a bunch of different subjects.
And how have the classes changed over the many decades you've been doing this? I mean, because we're getting insanely high-speed digital stuff these days, which wasn't around, really, 20, 30 years ago in terms of digital. It was all sort of, RF, but now we're getting digital operating at RF speeds. How has that changed the game?
Well, digital seems to be the big thing even today, and we're getting into more RF issues, okay, but I tend to emphasize digital in the class, although a lot of the grounding, cabling, shielding is applicable to pretty much analog. Yeah. Or pretty much anything, analog, digital, RF, whatever you want to talk about. So, and pretty much I cover stuff in all industries. And even though, as I said, we held in the Detroit area, it really wasn't emphasizing automotive necessarily at all.
Interesting.
Well, and at those speeds too. I mean, it's all analog at that point, anyways, right? I mean, it's a digital backdrop, but my inner analog guy is shouting, "No, it's all analog."
Well, my background is analog. I started, when I started getting into industry, digital was what didn't even exist really in the light of what we know it today. So my background is really analog. In college, I kind of specialized in feedback and control systems, which are low-frequency analog circuits, and kind of got into business with analog interference problems. So that suddenly got me knowing something about noise and interference.
Yeah, that's
great.
And
that's a great segue into when you got started, because you were born in, if I may say, 1936. It says in your book. Which makes you how old?
Did I put that in a book or something?
Yeah, it's in the book.
I was trying to leave that out.
Edition. Yes, it's part of the Library of Congress entry.
We can bleep it.
I think you did some investigation there or something.
Dave's a snoop. Yeah.
Well, it's kind of interesting how I got into EMC. Pretty much in a general sense, the way most people that have been in it a long time, it was an accident, okay? It wasn't planned or it wasn't any grandiose idea of doing this, but I was design engineer at AT&T Bell Labs, working on telecom stuff, basically, audio frequency analog type stuff.
And what year was this?
What year? Oh, this was... Well, let me go back a step further. So, after I got out of undergraduate school, I went in the Air Force for 3 years.
Okay.
And then I went to work for Bell Labs. So we're talking about 1960 when I started with Bell Labs.
Right.
Wow.
And
which is kind of the heyday, right? I mean, like it's 50s, 60s was kind of the really big time.
Well,
right?
the 50s, 60s, 70s. Yeah, you're absolutely right. And I look back and I say, because in the 60s was just when transistors and solid-state devices were coming into popular usage, the late 50s into the early 60s. Matter of fact, when I went to graduate school, we only studied vacuum tubes. We studied nothing about solid-state physics.
Right.
Now, I went in the Air Force between undergraduate and graduate school, and in graduate school we studied solid-state physics. But so I kind of feel that I've been in this business all through the solid state, industry.
The birth of solid state,
from
right up
crude discrete transistors to integrated circuits to large scale integration, et cetera. And I agree with you. The 60s, 70s, and actually 50s, 60s, 70s, and maybe into the early 80s was kind of the heyday of that industry, I think.
Mm-hmm. Is that because it was driven by the money from the Cold War? Is that Bell Labs did a lot of military stuff, right? Is that that was a lot of the reason for the innovation?
Well, I don't really know. I mean,
and then there was the space program, of course.
Well, that came along. Yeah, would that come in the 60s, I guess.
Yeah,
69,
early 60s, yep.
Well, no,
mid-60s,
well, actually,
no, they landed in 69, Chris,
that,
come on.
Yeah, it was later than that, probably.
Had to start earlier.
Yeah.
Yeah.
But, I don't know. It just seemed to be the heyday of learning things about technology and learning things about electronics. Mm-hmm. Well, I guess if I look back, I think it was the solid state age. Okay, it was the development of solid state electronics that made space for all the developments that went on in those days.
And would you go back to those days, or do you think technology these days is just so incredible that you'd never want to go back to the good old days?
Well, I guess we all look back and say they were the good old days, and
right, yeah.
The young people today will look back on their days and say they were the good old days. So I think there's something in every generation that's the good old days. I can talk about mine, but that doesn't mean, I'm sure there were ones before that and there'll be ones after that,
Yeah. I always think about it from the perspective of learning that kind of stuff as well. I mean, like, I think about the resources that are out there today with the internet and just being able to access a lot of the information. And I'm continually impressed with, looking at older texts and even like from a perspective of accessibility to computing machines of like calculators and stuff like that. Like that's what really blows my mind is just the basics have to be so much, or the fundamentals have to be so much stronger. Whereas today, I muddle through most of the time. I don't know about you, Dave, but
after 20, 30 years, I'm still muddling through.
Yeah, right. So,
well, I think that was also the age of a lot of these large industries like Bell Labs, IBM, RCA had big research labs. And, privately funded and really just with developing an awful lot of stuff. There's been a bunch of articles in some of the magazines, where have all the big research labs gone, which are pretty much all gone today.
Yeah.
If it doesn't apply directly to a product, nobody wants to work on it today,
Ah, right, yes.
So, at Bell Labs, not in the area I was in, but we had, large numbers of people working on something that had no product as an end product that was obvious.
Yep.
Right.
But,
right.
Sooner or later, something probably came out of it.
And how did they decide to work on these things? Did you have the ability just to work on anything, like you woke up in the morning, you had this brilliant new idea. Were you allowed to work on it, or how did the culture work there in Bell Labs?
Yeah, I think there was part of Bell Labs where that was true in the research. I was more in the development side of Bell Labs, okay? In the basic research, they pretty much could do somewhat what you were saying, okay? Mm-hmm. The culture there was just wonderful as far as driving innovation, and everybody talked to everybody, and you could go into anybody's office. And one culture that Bell Labs had developed that was different than most other companies at the time was other companies separated their electrical people and their mechanical people and these people, and Bell Labs intentionally mingled them all together. So you would talk at over a cup of coffee, or you would talk at lunch, and somebody doing something completely different would be down the hall from you. So this stuff would all get mixed up and come up with ideas that nobody thought of,
Yeah, that's great. That's one of my favorite things. I mean, obviously it's later, but in the book Bill and Dave about HP culture, which is an outcropping of Bell Labs, I think as well. It's the same kind of thing of like the coffee break time, 10 a.m. every day. The bell goes off. There's beer bus at the end of the day on Friday. That kind of same thing where these days it's all cube based and it's like, all right, do your work, go home, whatever, no big deal. Not all companies are like that, but I feel like that's common these days.
There's a good book out there on the history of Bell Labs. I read it about a year or so. It's good. It's called The Idea Factory.
Ah, okay.
There's a cute title.
We'll try and link that one in.
Yeah, The Idea Factory.
Yeah, that's a good one.
It's sitting somewhere in my office under something at the moment, but it's an interesting thing that goes through the development of Bell Labs. I enjoyed reading it because about half of it I knew being there, and about half of it I didn't know because you never know everything that's going on, obviously.
Right. Especially the size of Bell Labs, right? I mean,
yeah, and multiplicity of locations, etc. So it was a big thing. But
how did you, at a big company like that, how did you keep in contact internally in the company? I mean, now there's company email and intranets and all sorts of things like that. But pre-internet, pre-communications revolution, how did you know what everyone else was doing internally? Did you publish internal documents and hand them around. I mean, you didn't even have photocopiers back then, right?
Yeah. Are you asking me, was it life before email? Is that the...
Yeah, that's the... Well, even life before photocopiers, even before email, you would, pass things around in the company, you'd photocopy it and go, oh, read this, and...
Well, obviously, not as well as things go today, but... everybody wrote everything up as memos and everything was available. But a lot of the interaction was, as I said, just personal by running into people.
Right.
Or talking with people over lunch and, just informally.
That sounds better.
And to some extent, maybe that's a better way than all these doggone emails
all the
and everything.
Newfangled. Yeah, I think it could be.
Yeah.
I think it could be. Maybe not as efficient.
I was going to say, not as efficient, but... if you really know what you want to communicate, no. But as far as not knowing what it is you want to communicate or talk about, maybe the answer is yes.
Yeah.
Right.
Over a cup of coffee, you'll just talk about who knows what and come up with something. Whereas you're not going to normally write an email unless you got something in your mind what you want to say.
Yeah.
So sometimes just a discussion, but. I still didn't answer the questions how I got into the
No,
EMC.
that's right. Let's get back.
We kind of got distracted a little bit. But so I was a design engineer back there, and I got involved in a couple projects involving low-level sensitive electronics in a noisy environment. A lot of electromechanical stuff going on, big motors and brakes, and hence a lot of noise. And first thing I learned is, I knew how to design what I was supposed to do as an electrical engineer, but I had no idea how to control the noise because that was never taught in school and still seldom is, although there are a few universities that do. But so I looked in a library. There's a little bit of information, but not much. So I kind of had to figure out how to overcome these problems just to do my job. And suddenly I knew a little bit more about noise and interference than anybody else. And that kind of makes you the expert, Yeah. So that was kind of the gist of it. And then suddenly everybody started coming to me because Henry knows a little bit about that,
Oh,
they said Henry knows everything about it, but I knew a little bit about it.
Right.
Yeah. So, and
he's the
then
nice guy.
Everybody wanted to get into digital at that time, because that was a new thing. And I was never one to follow the crowd. So I said, I like this idea about noise and interference stuff. So I kind of leaned more to getting more and more involved in that.
That was with Inside Bell Labs?
That's with Inside Bell Labs, yeah.
And how long did you spend at Bell Labs all up?
I spent 30 years there.
Wow.
Yeah.
And then after Bell Labs?
Well, in another couple of years, I'll be 30 years doing my own consulting.
Wow.
So I think I'll have had two 30-year careers. And that's probably enough. But, what I did in Bell Labs, which I think is interesting, is I went to the people. Bell Labs was big on continuing education. They ran their own education programs, and
awesome.
They thought it was good to everybody to learn as much as they could or wanted to, and almost in any subject, by the way. So I went to the fellow that was in charge of our in-house education program and said, we need a course or a class on noise and interference, for lack of a better phrase. And because, engineers know how to do what they're supposed to do, design amplifiers, oscillators in those days, things like that, even digital lights, but nobody's learned anything about noise and interference. So he said, yeah, that's a good idea. So he said, I'll look into it. Well, but 6 months went by and I never heard from him. I figured he forgot about it, And about 6 months later, he called me up and says, remember you were down here in my office 6 months ago and you were talking about this noise and interference stuff. And yeah, okay. He said, well, I checked all our resources and nobody knows anything about it. So how can I do a class? How can I do a class? Well, the resources were basically twofold. They would go to the universities and get professors to come in and talk about some subject. Mm-hmm. And then their own Bell Labs engineers, especially, was telecom related. And of course, neither of those knew much about this subject. So being a kind of young, naive engineer, I said, well, then I'll teach one.
Nice.
And that really got me into doing this stuff.
Yeah.
And after about 5 years of teaching it, I had a big set of notes. And I said, well, maybe this would make a book. And I came out with my first book, Noise Reduction Techniques, Electronic Systems, back in 1976 as a result of that.
Right.
And
that is classic.
Yeah, that was the first edition. And how did you write the book back then? Did you do it on typewriter? Because we're once again, we're pre, right? I'm fascinated by how people did things in the old days.
I'll tell you, the first edition was 76, and the second edition came out in 88.
Yep.
Okay, the first edition was written by hand on paper.
Oof.
Right.
and went to a typing pool and was typed up.
A typing pool, yeah.
Yeah, well, that's a silly word today, right?
Yeah, exactly, but yeah.
And now the second edition was done on a computer, but not obviously personal. We had terminals on our desk with, one main computer at the company.
Yeah.
Right, mainframe business, yeah.
So in the 88, second edition that came out in 88 was done that way. But the first one was handwritten.
And what about any diagrams in it? I don't have the first edition. Did the first edition have, I assume it had diagrams and schematics, and they were hand drawn as well and then reproduced in the book, photo typeset?
Our art department did most of the drawings.
Right.
The Bell Labs art department. And it was virtually all analog. The first edition, I think, had about 2 paragraphs on digital.
Mm-hmm. Oh, that's interesting. Yeah, just because of the timing of it, right?
Yeah.
76.
And then the second edition had about 2 chapters on digital.
Mm-hmm.
And now my present book is about half on digital.
Yeah.
So interesting how times have changed there. But some very fundamental things like shielding, grounding, and things are the same really for analog or digital. It's just the frequency components are different. And
yeah.
One advantage I had is a lot of the things in the book were very basic, and they last even if technology changes, even if maybe some of the applications weren't very realistic at that point.
And so that was actually published through Bell Labs. I mean, there was another component of the learning program there, or how does that work?
It was published by Wiley, John Wiley and Sons.
Oh, okay. So it's published external.
Bell Labs was very, very much encouraged their engineers. They wanted to write a book or something, go right ahead. I mean, they had to approve it, the manuscript,
Mm-hmm.
Right.
You weren't giving away any secrets or anything, but...
and because this was, this is 1988, right? This is a hell of a long time ago. The second edition. Right. Yeah, is there any... ideas about a third edition? Is it needed, or is it just all?
By the way, the second edition in 1988 came out right after I left Bell Labs.
Right.
But I wrote it while I was at Bell Labs.
So it's copyright. That's why it's got copyright.
Yeah, the copyright
Bell
says
Labs.
Bell Labs on it. Yeah. Well, I started a third edition. That turned out to be my new book, Electromagnetic Compatibility Engineering.
Oh, okay.
2009.
I don't have that one.
Yeah, that's the newest one.
I had completely rewritten all but 3 of the original chapters, and added 6 more chapters to the book, and it was a completely different book in my mind. So we renamed it, and it's almost a 900-page book.
Wow.
Are the two? So the 2 books are different. People should get both. They're actually complementary.
Yeah. No, because you really don't need both.
Right, okay.
Because the new one includes pretty much everything that's in the old one.
Got
plus
it.
a lot more, and plus it up to date, So, it's not. It started out as the third edition.
Oh, okay.
But then, in the way things change, and I look at it, the noise reduction techniques in electronic systems was my experiences at Bell Labs, and electromagnetic compatibility engineering is my experiences after Bell Labs.
Got it.
After I had left there, so.
And you've got a quote in the second edition: "Everything should be made as simple as possible, but no simpler."
That's
Albert Einstein.
That's from Albert Einstein.
Yes. Why did you decide to put that in? In what
Okay,
way?
by the way, that's in all 3 books.
Right.
Well, because I think, so the question is why did I put it in the first book, really, is a lot of people writing books on cabling or shielding and things we're writing with a lot of field theory and very complicated. And my approach was to try and simplify it.
We like that.
and because I wanted to be able to understand it as a design engineer myself. So, that's been part of my success. I think that I wrote all the books, and this is the honest truth, for me to understand and read. Mm-hmm. And most design engineers appreciate that. So, I thought kind of what I did was try and make it a complicated subject simple. So I put that quote in.
Got it. And so you don't really need all that complicated field theory to do practical EMC stuff. Are there any cases where you do need to get that deep into the theory of it?
First of all, you're right. You don't need all of that. Mm-hmm. You need a little bit of theory if you want it to be more than a cookbook.
Right.
Right. And that's kind of what I tried to do. I don't think very much in the EMC business you need much of that theory at all. It's good to know some of that because it may lead you in certain directions, etc. Mm-hmm. But, the reason you got there, the way you got there might have been through some complicated field theory. But I think once you get there and understand it, you can simplify it. Well,
that applies to most aspects of electronics engineering.
I'm sure,
doesn't
yes.
it? I mean, not just, yeah.
Yeah, I mean, that's why I did it in one. There's no reason, and other people have done it in others, yes.
No, that's why the Art of Electronics book is so popular, because they deliberately don't include any of the heavy math. I don't think you'll find a single integral in the entire book. Yeah. I think that's the reason for their success. Otherwise, otherwise it's a book for teaching. It's not a book for the practical engineer.
If you think about it, who writes most of the technical books? Often universities.
Professors. Yeah.
Yeah, exactly.
And they're writing more the theoretical. And you don't get as many practicing engineers, at least back in those days you didn't.
Right.
Actually, writing the books. I think because they do their job and then they go off into something else. They're too busy. If I hadn't taught it, I probably never would have written a book. But I had a whole set of notes, and I said, this is useful for something, and maybe we could turn it into a book.
So as you were developing these notes, I mean, how did you go through and start digging into this stuff? Because I mean, some of your stuff in this book and some of your technical articles on your site and stuff, they're awesome, because I mean, like, this is like the practical stuff that I use all the time, like the mixed signal layout stuff. Like where do you connect ground planes underneath ADCs? Like that, doing that kind of stuff is just like, and there's so much conflicting information, and there's so much like just information out there trying to figure it out. How did you develop that course?
Well, especially on that mixed signal one is a good example, and it's a whole chapter in the new book on mixed signal. Yeah, that goes. But mixed signal is a really good example. That all of a sudden, I seem to get a bunch of consulting jobs with people with mixed signal problems. There was always some, but all of a sudden it seemed to come together all at once. I got 3 or 4 of them in a row, and I think my experience is it's often the problem of the year. Everybody seems to have this problem this year, and there are at least a lot of people in that problem next year. And I realized there was not a lot of good information out on it. So, like in the mixed signal, I wrote a little write-up on my webpage about it. And I got a call maybe 6-7 months later, editor from Printed Circuit Design magazine. And he says, I saw this thing on mixed signal on your webpage. And would you be willing to expand that into an article for Printed Circuit Design? And that was a good excuse to, work on it more. So I did that, and I wrote a little 4-page article. I think it was July 2001, or June or July 2001, Printed Circuit Design magazine. Mm-hmm. And from that, I developed a course on it. So it kind of just went on and on and on, But I think a lot of the things were like that because of problems I ran across in my consulting business.
Huh.
And some of those problems I didn't know the answer to, and then I kind of worked on them, or developed better answers to them.
Yeah. Maybe your fourth book, you shouldn't quote Einstein. You should, whatever that quote is, nothing is as powerful as what is it? Nothing is as powerful as an idea whose time has come, or something like that. Except you modify
something along those lines. Yeah,
you modify it. Nothing is as powerful as someone who wants to pay you to solve their problem. Right?
I wasn't smart enough to say that though, or do that at that point.
Do you have any idea how many copies of the book have been sold? A lot of technical books like this, especially if they're not standard university texts like basic physics or something, don't sell large quantities of book, at least like you read popular books, fiction or something. But the first two editions, I've done very good with selling those books for the market they're in. The first two editions of Noise Reduction Techniques probably combined sold about 70,000 copies.
Wow.
Nice.
And
that's impressive.
Yeah, that's good for a technical
book. For that
book
kind
like
of book,
this. Yep.
right.
Yep.
And, of course, the new one, Electromagnetic Compatibility Engineering, just came out in 2009. That's probably 5,000-6,000 copies total at the moment,
Right.
Something like that. I expect that's going to sell better in the long run.
Got it.
But
because, as you said, it really needs to be integrated as part of some basic course and things like that, because that's how most people get these books. It's the textbook they got during their course on that particular subject.
We're good. There's a couple of universities and colleges that are beginning to teach it as part of a graduate or undergraduate. Usually it's a senior elective or something. And for instance, the University of Michigan in Dearborn is one of them. And I'm going to start putting some stuff on my webpage about that. For people that are, as to, what colleges, universities, or even other consultants as well as myself, by using the book for teaching EMC as a resource if somebody's looking for education there. And so I hope to kind of, that's something we're going to work on adding to the webpage.
That's great.
Got it.
While I'm on the subject of books, I'd like to, you got a second here. I have, right now there's a lot of EMC books on the market. And I got this listed on my webpage too, but as long as we're talking here, I got what I call my 3-book mini EMC library.
Right.
You can buy a lot of books, and there's something good about every book. Some people cover something better than others. But obviously there's a lot of overlap if they're all on the same subject or whatever. But I got 3 books that if you buy them on the subject of more or less EMC and signal integrity, it covers the subject from about DC to light frequency-wise, and there's very little overlap. And they're all easy to read. And, so I think that's a big advantage to not have a lot of overlap. Now a lot of other books are good too. Reading and education is good, but if you want to limit yourself to just 3 books, I give you a recommendation. My Electromagnetic Compatibility Engineering would be the basic book. Then there's a book called High Speed Digital Design by Johnson and Graham.
Is that Dr. Howard Johnson?
Yes, it is. You familiar with him?
Former guest.
We've had him on the show.
And I know Howard very well. And
we've had him on the show for.
I'm sorry?
You are. So he's been on the show talking about his book.
Oh, okay, fine. He's a signal integrity guy. Yeah. Up in Seattle, Washington. I was Spokane, Washington area.
Mm-hmm.
Yep.
But him and Dr. Marty Graham, I know Marty Graham very well, who retired now from Berkeley University in California. But I consider that a crossover book. It's kind of a lot of EMC issues that begin to talk about some signal integrity issues. It's got a bunch of interesting measurement stuff in there that's not in other books, and it's also easy to read. So I'll tell you, out of all the books I've got, other than my own, I use that book more than anything else. And then there's a third one for if you're interested in the real high-frequency stuff, signal integrity, as things are getting more and more today, with almost the same title. It's called High-Speed Digital System Design. The word system is there. By 3 authors, Hall, and McCall. And it's not
Great.
not
Really?
too often
Great
that
list
three
of
authors'
names.
names rhyme.
Yeah.
All squared,
a lot of signal integrity books are very theoretical that are out there. But this is a very readable book. And I love the first sentence of the book, and I wished I thought of it. Out of a clear blue sky, the first sentence of the book says, "The speed of light is just too slow."
Right, that's great.
That's a good one.
And it really sets the thing about what the book is about.
Yep.
Just kind of like dealing
so
with
those
pop
three
delay, that
books
kind of
cover
stuff.
an awful lot without overlapping a lot. There's a lot of other stuff too you can get, but
Right.
I
Are you
often-
still doing research into the subject these days? Is there always more to learn?
doing research into it.
Yeah. Do you build stuff and measure
Do
things?
I?
And personally. Anymore?
My research is mostly in doing consulting, and sometimes I'll get an interesting problem that I'll kind of work on the side, trying to develop some other ways to do it, but not really a lot, between doing the training classes, public and in plant and consulting, that pretty much keeps me busy.
Got it.
No doubt.
Then I get a little hour free or something. You guys want to talk to me or something like that,
So we
So-
appreciate it.
That,
You do.
yeah. So
You're a busy man.
yeah. Well, I think you got to keep into the consulting business because that keeps me down to the real world, what's going on.
Got it.
Right.
Yeah,
Versus
if I just wrote books, if I just taught, you kind of lose what's really going on in the real world, and that kind of drives where I go. Like the mixed signal. I mean, because I had a couple consulting jobs with problems there, got me to, write the stuff on mixed signal, etc. Mm-hmm. Had I not had that, I probably never would have written the stuff specifically on mixed signal.
we have some questions actually from the audience that we should include as well.
Okay, I'll try and give them a
Hit it.
shot.
So a big question I always have as well, but FEWS on the forum wrote about. He was wondering about recommendations on shielding and shielding cans, and specifically, let's see. He heard that they can cause resonant cavities when soldered onto ground planes. Is this true or myth? And then there's a whole bunch of other questions, and then having them double as heat sinks. And well, let's start with that first one, perhaps.
About can it be a resonant cavity?
Yep.
Sure, but any shielded box can be a resonant cavity, and so what? It still serves a purpose, and you just got to live. Almost everything has a plus and a minus to it.
Mm-hmm.
Right.
And that's one example, but that doesn't mean don't use them. I would not think about stop using them or anything.
Right.
You just have to be careful when you have to know about it.
Yeah, and I think that's an important thing to know. I know when I talk about grounding, grounding is a very complicated thing. I don't want to really get into it here
No.
because I'll be for another 3 hours.
Yeah,
on
yeah.
it.
Right. Yep.
But I always make the point, grounding's a compromise.
Yeah.
Every ground system you or I have ever designed has faults.
Well, it's got to go
And it
somewhere,
has
right?
advantages, and the name of the game is trying to balance the advantages against the faults for the application.
Yeah. Definitely.
And I know some people argue with me that this type of ground has got this fault, and that fault. And I say, yeah, but give me a better choice for the application, and they don't have it,
Yeah.
Exactly.
But it's important, as you say, at least understand the faults and the limitation, and as part of your design and your testing, making sure it's not hurting you.
That's right, because when you finally test your product and you're getting some unusual problem on there, like there's some sort of this resonant cavities giving you, it's oscillating at some frequency. You're getting a weird, you test your thing, sweep it over frequency, and whoa, what happened there at 2 gigahertz?
And if you get something like that, so maybe you got to put something inside the can to break up the resonance or do something like that, but it's still serving the job of acting as a shield. So
Yep.
Yeah.
But you've got to know that it's caused by it could be caused by the resonant cavity effect. Otherwise, you might think, oh, is there a 2 gigahertz transmitter around here somewhere? Or,
well, you're right, absolutely correct. That's what I say. You always want to know the negatives as well as the positives to whatever you're doing.
Mm-hmm.
I had a coworker talking to me. So I mentioned you were going to be on the show today, and we started, just talking about EMI testing, being in anechoic chambers and stuff like that, and just, sometimes you put a piece of copper tape somewhere and it fixes one problem and the noise squirts out another side. It's just like,
well, that's absolutely true. And you push it here on a balloon, it pops out over there or something.
It just happens.
But that doesn't mean you shouldn't fix this problem, right? Then you can fix the other one.
Well, your boss is yelling at you one day. You gotta make him happy that day, and then the next day he yells at you something else.
We're in a boat and it's leaking, and there's 1,000 holes, and you're trying to plug them all before it sinks.
Yeah.
Oh goodness.
Absolutely.
So is that coming from? So you said you primarily have a development background. Is that from the the hands-on practical approach? Because I can imagine that someone with more of a theoretical background being like, well, let's go back to first principles and stuff like that. I mean, is it just because of the development background that you had that?
I think so. As a teenager, I've always been hands-on building things and doing things, and. I got into engineering. My interest in theory is so that I can build something or make something, not in the theory itself.
Mm-hmm. Right.
So I think I come at it from the bottom up, and some of the university people come at it from the top down,
Yeah.
And, but the theory down, I start from the practical up, You got to know enough theory from the practical to know what you're doing.
Do you think they're not teaching enough of that these days? Are you getting a lot of young graduates in your courses?
We get everything from young to old, and I think engineering education does have a problem today.
Right.
You can get a bachelor's or a master, and even a PhD in some places, without ever studying a field theory course or anything like that, especially in computer science, where they just talk ones and zeros.
Yep.
And I think, it's hard to argue. There's so much to study. I'm not saying you shouldn't do that, but they're taking out a lot of the fundamental stuff, I think, because they're saying, well, fewer and fewer people need it,
Right, because there's so many off-the-shelf solutions out there. I mean, now we take it for granted that we can just go to DigiKey and buy 200,000 chips that do everything. It's basically a modular plug-in.
Well, and I think that's right, because as I say, I kind of worked through this whole solid state development from.
Yep.
When I started working solid state, we designed transistor circuits with transistors. Now It's more like a systems engineering. Everything is in a box called an IC.
Mm-hmm. Yeah.
And all you do is interconnect a bunch of boxes.
Yeah.
You don't necessarily know what's going on right at the device level.
See, the only thing I think that's different these days is that, I think about your mixed signal, like this mixed signal article I've read like 3 or 4 times in the past year at least, because this is where the rubber really hits the road for me at least, right? Because I am just integrating ICs and stuff like that. I am just connecting up these boxes, but then it comes down to that point of, well, I know ground loops are a thing. I want to make sure that I have that right, and then it's like. And then you kind of get to that point and you start focusing on this problem, and it just, your whole world explodes, because it goes from, I have this simple chip, it seems like, to start with, and if I step outside
it suddenly become complicated.
Exactly, yeah. It opens up the entire world of, oh crud, what the heck am I going to do about all of the things that can go wrong? And the fallback is, of course, to go back to the vendor and be like, do you have recommended designs? But then if you have to move outside of that, then you have to.
Well, you're right, and that's the problem, as I say, that a lot of people aren't learning the fundamentals today. You look at digital logic. To a digital designer, there's a 1 state and a 0 state, right? Mm-hmm. And there are no EMC problems in a 1 state, and there's no EMC problems in a 0 state.
Right.
All the EMC problems occur in the transition, and the transition is an analog state that the digital designer doesn't think exists.
Right.
And it's much higher frequency than your
absolutely
1-0 rate, because it's all about the transition rate.
Right, because digital designers are RF designers and don't know it.
Right. Mm-hmm. Well, the good ones are.
Right.
And, the good RF designers know what they're doing. They're doing RF and they understand it, but the digital people don't think they're doing that.
Yeah, I have a firmware guy I work with, and he's, we hit a problem, let's pull out the logic analyzer, and I'm like, yeah, that works when you need to know what word you have when the signal's clean. I'm like, there's like a whole lot of other stuff that's going on between.
Let's get the oscilloscope instead of the logic analyzer. Yeah.
Right, with noise. That doesn't help you much in noise interference or EMC.
Yeah. Do you have do you have go-to tools that, we always like talking about, test gear and stuff like that on here. Do you have go-to tools that you recommend for people that maybe starting out or getting into the more serious side of troubleshooting?
What are you talking, software tools?
Oh, no, I meant like hardware too, like even like specific scope types or stuff like that for chasing down EMC problems.
Well, some small probes, little magnetic loop probe to probe what's up on the board, and we use a common mode current probe that goes on cables to measure the unbalanced current on the cable that causes them to radiate.
Yeah,
they're probably the two most useful things.
But almost nobody would have one of those in the lab, right? No. That's one of the problems. I guess
that's the problem. Yeah, you're
is that
right.
It's not a general purpose bit of kit. Should it be? Should the scope manufacturers be actually providing one of those for?
Yeah, and people don't know what to measure if they were to measure from an EMC point of view.
Exactly.
And because the other thing is, those two probes and the spectrum analyzer. Engineers often don't even know how to use a spectrum analyzer.
Yeah.
You learn using an oscilloscope in school and a voltmeter, okay?
Yeah, right.
But a spectrum analyzer is a complete other beast.
Yeah, I think I muddle through with, like a lot of the new scopes have FFTs on them. That's kind of the best I can do with, see some frequency content and do what I can.
I used to always say that the big problem price-wise here is spectrum analyzer, but we now have some really good ones that are very inexpensive.
Yeah, they're down to like $1,400 or something.
Well, you can get one I often mention to people is a Rygold.
Is it the Rygold 815?
Yeah.
Yeah, I've got one of those here in the lab. Yeah, it's only $1,400, including tracking generator.
Yeah. And that's it's a well-built thing. It works very well. Got a good frequency response. It's not a cheap spectrum analyzer. It's an inexpensive spectrum analyzer.
Yeah.
And there's a difference, right?
Right.
Yeah.
It's well built, and so there's no excuse now because the scope costs more than that today. A decent scope,
or a decent bandwidth one, yeah.
At least as much as that. So, people can, like one of the one-day classes I do is on a thing we call workbench EMC measurements you can make in your own lab that relate to EMC.
Right.
And that's a lot of people are interested in that because, like you said, they don't do these things because they don't know what to do.
Yep.
And they don't know what they're looking for or what equipment to use.
Got it.
There's a whole chapter again in my book, my new book on what we call pre-compliance EMC measurements, all done with simple equipment.
Yeah, that's a big thing these days because you want to ensure that your design is at least in the ballpark before you go and spend tens of thousands of dollars getting it compliance tested.
That's correct, but many people don't do that. They go and spend the $10,000 and find out that they fail.
Yeah.
And quite often they fail so bad you could have found that out in 10 minutes if you just did a couple quick tests yourself.
So you're saying that your book is going to save people $10,000? Because I say right there that should be your sticker on the front.
You read that one chapter.
Yeah, exactly.
What is there any like a really common mistake that people make at that EMC? That causes them to fail EMC compliance.
Sure. There's about 10 different things I've done.
Well, if you that'd be great.
Let me just give you a couple.
Yeah, please.
Let me just give you. By the way, again, I have an appendix in that new book. I was going to put the 10 most common EMC problems, but that kind of sounds dull subject. So
that's a great topic.
But I wrote
that
this
as
chapter.
A subject heading.
No, I wrote the appendix. The 10 best ways to maximize the emission from your product. And I wrote the chapter said, do this, do that, do the other thing.
Yeah, that's great.
Now, the book's been out for, 2009, 4 years now. And I got one email just a week or so ago from a guy that says, I was reading that appendix. Aren't we supposed to minimize the emission? He doesn't get it. Okay. But the idea was kind of to turn it around, make it a little bit interesting. And,
that's awesome.
Oh, that's and a lot of EMC people read it and think it's great because they say there's so much truth in it, that people do this. Uh-huh. And I kind of prefixed that in the beginning. I don't think this appendix is needed because most people do this anyhow. So, they don't need me to tell them. But let me give you a couple.
Please.
Basically, what I refer to is an interrupted return current path, where you run traces across splits in planes.
Uh-huh.
If the adjacent plane's got a split in it, the return current should be right underneath the trace. See, everybody thinks of the signal current. Everybody forgets about the return current.
Oh, yeah. Definitely.
If it's right under the trace, it's a nice small loop, that's a good thing. But suppose there's a split in that plane or a slot in that plane there.
Mm-hmm.
That causes major problems, okay? The second one would be terminating shielded cables improperly with long pigtails.
Uh-huh.
Or with pigtails at all, as a matter of fact. It should be a 360-degree termination.
Right.
Just those two things would make tremendous differences if people would realize and correct those things,
Traps
for young players.
Two good pieces of advice, I think.
Yeah. Do you visualize current like a train, like a bullet train? Because that's kind of how I do it. I think about where the current's going and where it doesn't want to, like the quote unquote wants to go, and then if it runs into something it doesn't like, it's gonna be like, nope, I'm gonna start radiating like crazy because it's gonna do whatever it can to get across there.
Well, I don't know that I looked at it like that, but I think the net effect is the same.
Yeah.
The way I look at it is always loop area. How big is your loop?
Yeah.
You always want to minimize the entire
That's kind of what I do.
That is for me,
that
it's
relates
number
to
one
the
rule.
practical solution.
Yeah, that's right.
Yeah, I look at loop area. But you see, how many people look at the signal part of the trace, and then as long as there's a ground symbol on both ends, they figure somehow it gets back.
Right.
and never give a microsecond of thought to exactly where's that return current flowing.
Yeah.
Mm-hmm.
Somewhere in the ground, right?
Yep.
Yeah, I've seen people suggest that they actually draw individual ground returns for beginners, especially, so that it's a really clear concept of it's not going into some ether and below your board. No, it's going back. It's got to go back.
Right. Well, yes. So many people think that ground, is a one-way thing. You can just dump current into it and it disappears.
Yeah.
Yep.
And that's not exactly true.
Yes, it's not a well.
I've done a video on that. I've done where I use a current tracing probe and I trace the return current through a ground plane, and you can show that no current flows down this area here. It's all flowing through there, and it's
absolutely,
and then people just go, oh wow, I didn't know that.
Yep.
I had no idea.
Yep.
Whereas the flip side for that, right? That people, that's like one of those wow moments for people. But just the other, my latest video is a measuring noise in op amps, right? And the feedback I got from that is who cares?
Yeah.
I don't want to know about that stuff. That's boring. Go away. Give me something more interesting. And I find that a bit disappointing because I think it's important, to know about noise in op amps, for example, and the different types. But a lot of people seem to think this is boring stuff, unfortunately. How do we get them to be more excited by it? I guess they have to be bitten, right? They have to have a problem where they have to be bitten on the bum.
Yeah, I guess so. That's an important issue, important point here. And how do you get people to realize it's important? This whole subject,
I don't know. Have you got any good advice?
Yeah, maybe we'll have to open that up to the comment section for because I.
Well, a good friend of mine, Dr. Clayton Paul, who taught at the University of Kentucky and Mercer University, just passed away last year. It's a sad thing, but he was a real good EMC guy and a real good professor. But he used to teach an EMC class. And he had a hard time getting students to attend the class because they didn't think it was important, And he said, I got to find a way to get them to attend the class. So he also had a basic circuits class he taught that had a lab associated with it. They'd build a little digital something as part of the lab. So he got the idea. he says, all right, he took his circuits class. He says, we're going to build this little thing, but let's say it's a counter with a readout or something. But instead of putting it all on one little board, we can put on two boards and a meter-long cable between them.
Nice.
And everybody did that. They made it work, and maybe the first thing they ever built made work. They thought, they knew everything in the world. And then he had arrangements with IBM in Lexington. He brought him over to their EMC lab, and he measured the radiation from it.
Yeah.
And he said, you couldn't sell this thing anywhere in the world.
Yep.
Yep.
And you know what? After that, his EMC class would fill up.
Yeah, I bet that's brilliant.
Because now they relate, well, maybe this is something I should learn about.
Yeah.
A lot of engineers in the field don't appreciate the importance of EMC. Surely the students don't. They haven't got to the level yet of, understanding some of the other things yet. So EMC is the least of their concerns. And so, but
I think personally, I get away with a lot just from being a lower speed kind of stuff. I mean, that definitely helps. I think from the grace of like I said before, even app notes, having suggested layout, that kind of stuff, that takes people a lot further than it used to, right? Where maybe there weren't as good of application departments, but it's just glossing over stuff, right? I mean, it's still there, and these things are still determined at some point, but it's just either it's pulled into chips application departments, or it pops out later once the engineer doesn't realize it, like when they go into EMI testing, that kind of thing. Yep.
And especially when you're into high frequency stuff.
Oh yeah. What about like DC to DC stuff? I mean, we were just talking about loops and stuff like that, and that's what whenever I hear loops, I immediately think of like,
right.
like DC to DC control circuits, switching regulators, that kind of stuff.
Yeah, DC converters, that kind of stuff, very very noisy stuff, and that produces a lot of conductive noise problems.
Mm-hmm.
And I'll tell you another thing right along those lines that pretty much behaves is that's coming into fashion is variable frequency motor drives.
Oh yes,
for like efficiencies and stuff,
where they control the phase of the speed of three-phase AC motors electronically. Matter of fact, those motor drives are basically almost like DC to DC or AC to DC converters, but instead of producing a voltage as the output, they produce a drive to the motor, and they got all the switching noises and everything. So I see a lot of problems with that recently. And that's the automotive industry too, because that's what you have your drives on your electric cars.
Of course.
Oh, really?
Yeah.
Interesting.
Yeah, that's a big deal.
Matter of fact, way back in the beginning when I was thinking, people talking electric cars, I figured they got DC motors. They get three-phase electric motors, 400-volt three-phase electric motors.
Right, that's a lot of
driving those cars.
They're portable EMC generators, right?
Absolutely.
All over the country.
Is there any industry emission requirements for those instead of exhaust emissions? Is there any, EV car, radiation standards?
There are.
But are the automotive industry actually going to have their own set of standards for that, or is it just like a regular FCC sort of requirement? Does it? Well, do you treat a car as a regular product, or?
Yeah, a car is a regular product. There's a lot of them around. It doesn't come under FCC, by the way. But
okay.
The European Union has their own requirements on it that the car manufacturers are required to meet. And most of the car manufacturers have their own requirements, interestingly enough, as far as radiated emission, more stringent than the FCC. And you say, well, why do they do it even more stringent? Well, because they got in a small space called a car, an antenna sticking up with an AM/FM radio. Now, when you buy a $20,000 car, you expect your radio to sound without noise and static.
Yeah. Of course.
I don't know why you have that crazy idea. But so, I mean, a simple thing is you can't listen to your radio comfortably is a reason to downgrade that car.
Yeah. Yeah, of course.
So they put emission requirements on themselves that are about 40 dB below the government's.
Wow.
Right. Jeez.
Yeah, because the damn antenna's sitting right next to this microprocessor that's in the car,
I've heard about new parts coming out actually, where they tune the DC to DC to chase the AM or FM tuner effectively, so that it's always like a certain amount away from that switching or from the antenna. I think it must have been AM because of the switching frequency. Yep. But they chase that around so that as you tune your radio, it doesn't pick that up, which is brilliant.
Yeah.
But once again, there's a problem that's solved by one of these chips, or potentially solved, and then you don't understand it, right? When you're from the design point of view.
Yeah, unfortunately, automotive usually does a good job, even on susceptibility, because you drive your car maybe down by the airport or by a building that's got a big FM transmitter on the roof.
Yeah,
you may drive through a very strong field.
Yeah.
And you don't want your engine installed
or your airbags
because
going
of interference with the engine control
right.
circuit. So you don't want your cruise control to go crazy.
That's it.
So they automotive has a lot of. It originally started out as self-imposed restrictions just because of what the product is,
right,
and what the customer's perception of the product is and what they expect. So
Is there a big difference in terms of trickiness and traps for young players between conducted and radiation emissions? Which do you find more troublesome? Is there more people have problems with radiated emissions
conducted?
or conducted?
Yeah, normally radiated.
Right.
Okay, too. Well, first of all, conducted is mostly below 30 megahertz, radiated is above.
Yep.
But you know where the conductor is coming out.
Right.
On the power line. So you know where to put the filter.
Yeah, any cable coming out. Yeah, unless you've got a sealed
but
box with batteries
the
inside.
radiated could be anywhere. Radiated could be on multiple cables. Radiated could be through the enclosure, etc. So it's a lot harder to control, and therefore most designs are, they control the conducted well, and but clearly the radiated is more of a problem. Now there's always somebody that's got the opposite, but if you just look at all the problems in the world, radiated is more of a problem.
And there's a lot of people who think, well, I'll just whack it in a shielded box and I'm done, right?
Faraday cage, everything.
A lot of people think that.
I think you've got an excellent graph somewhere in your book about the different types of shielded materials and the frequencies they operate over, if I remember that correctly. So you may think, okay, I put it inside an aluminium box, but that only works over a certain frequency range. Is that right?
Well, it's mostly the apertures. The problem, the shielded box has got seams and apertures. Designing a good shielded box is not the simplest thing. And if you've taken the approach you just said, you're probably not designing a good shielded box.
Right.
Because you haven't thought about it. Besides that, cables go in and out that bypass the shielded box.
That's it.
So you not only got to design a good shield, but you got to filter all the cables. And ignoring proper design and just using a shielded box is not the optimum way to design cost-wise or anything else usually.
Yep. So what is the proper way?
You're right, a lot of people just say as a last resort, we'll just put it in a shielded box.
Yeah. So what is the proper way to get a good shielded box? Do you solder all of the complete seam around the outside? Is that the belt and braces?
That would work fine, but it's not very practical.
No, that's right.
Your manufacturing floor hates
you gotta limit the maximum dimension of any seam or aperture, cooling hole, etc., in order to limit the radiation through it. And especially in seams, you gotta have a conductive finish on the seam so that when they're pushed together, they make contact, etc. So, designing a good shielded box is not a trivial job.
Right, so you can't just get a die-cast alloy box and then just screw on the lid and think that you're, going to get get performance from DC to daylight.
Nor just tinfoil like I would do.
Well, at high frequency, the thickness of tinfoil is fine. It's not really the thinness. It's just, you end up making it a really good enclosure.
Yeah.
Right.
Huh.
With no penetrations of it.
So you don't really have to worry about radiated emissions below generally about 30 megahertz? Is that you're generally not going to get too many issues?
Well, not regulatory-wise.
Right.
The regulations do radiated emission testing above 30 and conducted emission below 30.
Got it.
And now there's always exceptions to that. I mean, yeah, there have been radiated
AM radio in your car, for example.
Yeah, right. But the rationale for that is that most products are not big enough to be efficient antennas below 30 megahertz.
Right.
Just because of wavelength and everything.
The radiation from them isn't too much of a problem. However, the AC power line they're connected to is a big antenna.
Oh, yeah. That's a big wavelength. That's it.
Yeah, and I can't very well measure the radiation from the power line and not pick up anybody else's radiation. So they're going to tell you how much you can excite the power line. That's really the conducted emission test.
Yep.
The conducted emission test is really a radiated emission test in disguise.
Right. Are there any common traps that people fall into in terms of, mains-powered products? Is it adequate just to put one of those IEC mains input filters there and be done with it and wipe your hands and go, that should be enough?
If you mount it properly and ground it properly and it's a good design filter, it might be.
Right.
So there's a lot of times you can get away with doing that. But, the one I find mostly with filters is power line filters, is they're not mounted well. And they got too much parasitic impedance.
Oh, in terms of the connection of the metal case of the filter to the back panel?
the metal box of the filter to the chassis.
Right.
Or I've seen people take the power lead into the filter and the power lead out of the filter and wrap them together.
Right.
So you couple all the energy around the filter, basically.
Exactly. You've just got capacitive coupling.
But it looks nice. It looks nice routed like that.
Right.
That's right.
But you get the sticker too, right?
I would say interesting on power line filters, an interesting subject. I would say 90% of the times I fix a conducted emission problem with a filter, it's mechanically, not electrically. It's the mounting or the wiring of the stuff.
And the physical wiring, and people forget about the capacitive coupling between the wires when they cable tie them all together, right?
Right. And
it just sneaks right past the filter. It just bypasses it.
Unless you got a very noisy product, if you buy a commercial power line filter, the power line filter manufacturers have got the design of those filters down pretty damn good.
Yeah.
Right.
Yeah.
And if you implement them right by mounting them properly and use them properly, they usually, you can almost do what you said, just put them in and forget them,
Got it.
But it's so easy not to mount them right and put them in right there.
Right.
So it doesn't actually work out that way all the time. Yeah. That's a good question.
How many people actually come to you, screaming, "Oh, my product doesn't work.
Yeah, I was wondering about this too.
Is that the majority of your business, or?
Well, no, and I'll tell you why. There's a lot of people do that. Because we do a lot of training classes. And what that means is I've often got commitments next week or the week after. Like next week, I'm going to be in Tucson doing a class for somebody. Last week I was in the Detroit area. So if somebody wants it fixed next week, I say I can't do it. Because I got other commitments. So, if it's real quick emergency, I usually don't end up doing it because my schedule is such I can't. Besides that, I'm not crazy about, those kind of crisis problems,
Yeah, right. Yeah.
But although I work with people fixing things after the fact, it's usually when they're not in as much of a hurry. But the ideal thing is working with them before the fact, just coming up with something new, and let's kind of try and do it right to begin with.
Do you charge them like an idiot tax because they've been on your course and it's like, and they completely ignore everything you said, and then they come screaming back and it's like
that's a good term too. I think I should. I'd probably be rich if I did that. But no, the only once that I charged somebody extra because he made me work on Sunday. He wanted it done
right.
Oh jeez,
But no, well,
oh, that's great.
I know some consultants that if you hire them and they tell you something and you don't do it, they get upset.
Right.
I don't. Yeah. My feeling is you hire me, you want to know what I think is wrong with this, how to fix it. I tell you, I did my job, I earned my money. Now it's your responsibility to do it or ignore it. I don't care.
Yep. Right.
I don't get upset. Yeah. I know people do get bent out of shape about that. I don't care. I did a good job. I earned my money. I feel happy with what I did,
Right. Mm-hmm. And you'll happily come back and tell them the second time, right?
Advice, that's okay. Be my guest, And sometimes they don't, and sometimes they do, Usually, more often they do than don't, but there are examples of both. And a lot of times I don't know because you tell them something and you go away and you don't hear from them. Mm-hmm. So either they're mad at me, they don't want to call me again, or it worked and everything's fine,
No thank you notes?
I don't necessarily know.
How much of a big deal is ESD these days?
These days, it has always been a problem. The European Union has mandatory requirements for ESD. The U.S. does not on commercial products.
Okay.
I do a reasonable amount of ESD consulting for clients.
Are there any common problems there traps that people always fall into, in that they haven't protected their gear properly?
Well, a lot of it twofold. Some mechanical. You want to try and keep the ESD out as much as possible,
Right.
And putting breakdown filters and things on I/O cables, etc. Number one. Then what I do is I go and put filters on the digital logic, on the resets and the interrupts and things like that. So even if a transient gets in, it doesn't upset the logic. Usually, especially in digital circuit, which again most things are today, the ESD problem is one of upsetting the logic and having it change state.
So is there a way you discern between one type of signal? I mean, reset's a good one, but do you do chip selects as well for like a SPI bus or something like that? Like anything?
I'm sorry,
really,
do what?
Like a chip select on a SPI bus? Would that be something you'd also do, more internal to a part, or is it mostly kind of the outward facing where the human interaction and
well, I do two things. I where the cables enter, I try and protect that, and then I go and try and protect the sensitive IC devices.
Okay.
And that's kind of my approach, to go both places.
That's good thinking.
How? What sort of issue do people have? A lot of issues these days with low-level component noise and stuff like that. Is that still a big issue these days, or people are sort of beyond that because it's all designed out because of the system blocks they've got these days?
I guess, what do you mean by low-level component noise?
Oh, op-amp noise, thermal noise in resistors.
The inherent noise,
electronics. Yep.
Internal noise, intrinsic noise sources.
Yep. Intrinsic noise.
In fact, there's a chapter in the book on that. Not as much. You normally only get that if you're measuring very, very, very small signals.
Yeah, so it's more of a niche market
and that's very, very specific type of application. So
that can get really tricky.
Yes, it can.
Every once in a while, I did do some consulting for a company that's measuring very, very small small signals, and that can be an issue there. Yeah, but not as much. No, that's not a big issue that I get involved with nowadays. Right. I don't see it a lot.
I always find it amazing how the manufacturers, Analog Devices will come out with the world's lowest noise op-amp. And I'm going, well, how the hell did you measure that? How did you characterize that?
That's true. And that's a lot of work, and it's difficult.
It's just almost black magic,
Some Keithley gear, man.
Yeah.
Some Keithley gear. Well, how did Keithley measure their own gear,
Yeah, it's... some better gear than that.
Yeah. Right.
Metrology sciences are crazy.
Got it.
One last question. I mean, we're kind of getting out there on terms of time, but so you are a lifetime member of the IEEE. What does that mean? Does that mean you get
a member till I die?
It means he's been a member for a lifetime, which is
so lifetime.
When did the IEEE start? I don't even know. Is it in the 1800s?
Well, there's two questions here. Let me answer the lifetime question first, okay?
Yeah.
What that means basically is you get your dues free.
Oh, nice.
Right.
Yeah. And like lifetime member of, you can stop paying them, you know.
Yeah.
Right.
And lifetime member of the IEEE EMC Society, you can attend the symposiums for free.
Oh, nice.
So there are some nice advantages to that, and that's usually it's a result of being a member for a long time, having paid dues for a long time.
Buy 40 years, get 20 free kind of thing.
Is something like that. Yeah,
that's a good deal. I like that.
You know, you talked about when did the IEEE start? I think, didn't you say?
Yeah. Yes.
Well, when I was in college, there were two professional organizations, the AIEE, which is American Association of Electrical Engineers, and the IRE, which is Institute of Radio Engineers. So there
no mention of the word electronics back then.
Most of it was, the AIEE, back then, the two branches of electrical engineering were power and RF.
Yeah.
Right? That's all there was.
Yep.
And the AIEE was the power organization. The IRE was the RF organization. And in 1963, they combined to become the IEEE.
Ah, got it.
So it's a combination of those two professional organizations. And so the answer is 1963, and it was a combination of those two. So if you were a member of one or the other, then you ended up, a member of the IRE, AIEE.
Are there any more books in the planning stages?
What, that I'm working on or I'm thinking about?
Yeah.
I'm thinking. But
or is it just too hard? Because it takes years to write a technical book, right?
Yeah, it really does. I mean, the last one I came out with, which was, it took me 3.5 years, basically.
Wow.
Plus, I'm working, doing consulting work and everything, too. But, it's an awful lot. And I put off doing it because, as I say, it started as a third edition, but the publisher was after me to do a third edition, and I just knew how much work was involved, and I didn't want to commit myself. And I finally said, if I'm ever going to do it, I got to do it. So I decided to do it. I go slow on doing that. I have a thought with another fella. Maybe we're going to come up with something. I don't know.
Sweet.
Got it.
But it'd probably be on antennas if it's what I'm thinking about. But
okay.
Something different.
Interesting.
Simplified antenna theory.
Oh, I like that.
That'd be nice. Yeah. Are there any good books on that at the moment, or is that why you're thinking about it?
Well, not on Simplified. There's a lot of good antenna books, but they're all
of course.
They're all very loaded with theory,
Of course, yeah. No, I'd certainly buy that.
I would too.
Because that's another thing people don't understand.
I kind of took a lot of stuff and tried to simplify it, and maybe that's a thought of doing that with antennas also.
Could you do that for everything? Because that would be great for me.
You could do some degree of simplification. I mean,
But, what subjects in electronics do you think can benefit, are in need of a real simplified text? Have you noticed anything I'm sorry, have you noticed anything in the field that needs a more simplified text, that's just crying out for a simplified book? And antennas being one.
I think in any subject you could do that. But I don't.
Excellent. Digital for dummies?
I was going to say all those for dummies books,
Right, yeah.
Now, some of them are too simple, but a lot of them are good,
Yeah.
But I think, if you get the right people that know how to do it and are interested in it, you could have a book on simplified everything.
And do people, is that, the practice in engineer, right? Because most people, they do this engineering study and then they go into the real world and they actually make things. Is that all they have to worry about these days, is the practical side of things? Is theory, do they have to go deep into the theory anymore? Is that an important thing, especially in the education side of things? Should they be teaching more practical stuff?
Yeah, well, I think education should cover more practical stuff, but the universities tend to think otherwise, I think, in general. I mean, don't get me wrong, the theory is important. Understanding theory and developing like some of the exotic communication codes and things like that we use, and modulation schemes. Yeah. I mean, even FM radio was something fairly complicated to understand until the people worked out the math. So, you often need the complicated theory to work out some of these schemes. But then once we understand the scheme, there's no reason you can't simplify it, is what I say. I don't think you can come up with everything in the world without knowing a lot of maybe complicated theory. But once we get something, I think we can simplify it down to a more understandable thing. And I think frequency modulation would be a very good example of that.
Who was it, Chris, that we had on about the TV stuff? Was it
Ron Kwan, yeah. And he's actually doing a book on FM, I think, soon.
Yeah, he's doing a simplified book, I think. And just like the art and science that went into doing the beta and VHS video recording schemes, very complex stuff behind that. Phenomenal.
Yes, yeah, I mean, well, that's a good example. Yeah, absolutely. And
do you think that there's any hope of the Bell-style research labs coming back in favour? Is there
that's a good question. That's a real good question. I think when they were here, they were a national resource.
Yep.
Do I think they're going to come back? No. I think everybody's too focused on the short term and
profit, and products and what product can we get out in the next 9 months?
What about Google, though?
By the way, more and more, it was in the next year and the next 9 months, now next 6 months, now next 3 months, I think. If you can't get on the market next week, forget it.
I was going to use the example of Google there, Chris.
Yeah.
Because they've got like a basic sort of research lab. Those big companies, there are a couple around that, do think that basic research is... the ones that are very cash heavy and they want to, get a tax exemption on the R&D side of things,
Well, God bless them.
Yeah.
Well, I think the one thing that we're seeing too is so many companies and things are getting out of the hardware business just to get into systems and software.
Yeah.
Right.
And we're moving so much of the hardware stuff overseas, out of the United States.
But is there a lot of innovation happening? Well, I know a lot's still happening in Europe and in places like China. I don't hear too many stories about there being huge, basic research innovation in China yet.
No, not that I'm aware of. And
so who's doing it? Somebody's got to be doing it.
I think
We've got to be
universities.
advancing the state of the art somewhere. Yeah, universities are still doing it, of course.
Yeah, if you look at products that last 10 years or so, who's been the most innovative? Apple.
Yeah, that's true.
I mean, iPads, iPods, they were products that didn't even exist. They're not just changing the computer. They come up with products that didn't even exist.
But are they developing the basic technology behind it, or are they more of, system-level integration masters? I guess is the question.
The idea first, is to even think that this is what you want.
Right.
And,
and then how to achieve it.
When
we want to go to the moon, how do we do it?
A guy I always respected and was Steve Jobs of Apple.
Mm-hmm.
And at one time he had a job at Apple. He was called a corporate visionary. And I, in my mind, laughed at that. That's just an excuse to give him an office and pay him. But, if you look in hindsight, he was. He just came up with product. I mean, he not only changed electronics, iPads, iPhones, things like that. He changed marketing, the Apple stores, okay? He changed animation, Pixar. I mean, he had Pixar. He sold it to Disney for $7.5 billion.
Crazy.
That's what he did when he wasn't at Apple. You know what I'm saying? Yep. And so marketing. If you look at the, I've been reading a bunch of stuff on this recently, and they claim that the Apple's the most successful retailer in the world right now. Mm-hmm. The Apple store in New York City grosses more than Tiffany's Jewelers, which is down the street.
Oh, wow.
And they just put a whole new spin on marketing. So, he came up with new ideas. And like the old story of a paperclip, a new idea doesn't have to be complicated necessarily.
Mm-hmm.
It may be, but, it just division something.
So have we moved into that era where, well, we're not going to, it has to be product-driven research rather than just, look, we're just going to do a whole bunch of basic research and we have no idea. Are those days kind of gone? Do you have to have some sort of end product idea in mind or end application?
I don't know, but
end vision?
I think in most companies that's true. Now, where there may be some basic research is some government-sponsored stuff.
Mm-hmm. A DARPA? And
that would be one example.
Military stuff, is that? Yeah.
And, so I don't know. I mean, who knows where the next innovation is going to come from? Somebody just gets an idea and it grows. But it's really an interesting field to be in and see what's going on here. Would any of us predicted what we have today 10, 15 years ago?
No, I mean, nobody predicted the internet, for example.
No.
Things like that.
No.
It's just,
yep. You're right.
Nobody predicted mobile phones. I mean, back in the day, nobody.
Well, I was at Bell Labs when they developed the version of cellular phones that we have today.
Okay. Yep.
AT&T didn't realize the value of it.
Yes. Yep.
Nobody thought mobile phones would become the primary phone. A lot of people are getting rid of their landline.
Yeah, that's exactly.
Me. Nobody ever envisioned that. The original mobile phone service was just an improvement in mobile phones for those people that wanted it or needed it in a car or something like that.
For that niche market. They thought it would be a niche market.
Nobody envisioned it. And phones, we got internet connection and everything. The smartphone is a whole new technology.
Yeah.
Mm-hmm.
The phone was a phone.
Yeah, that's it.
And maybe a camera on it. That was it.
So we do need these visionaries who can, think 100 years into the future. What are we, or 50 years or 20 years? What are we, I can see this being a big thing, even though you don't think so.
Yeah.
You think it'll be a complete flop. But I'm a visionary.
We got some companies, not necessarily electronics. I'll give you a good example. Like SpaceX is a good one.
Yes.
They're sending commercial spaceships up to the International Space Station.
Yep.
And who would think that, they would have come up with schemes to do that.
And they're headed to Mars.
Yep.
Yeah.
Fantastic.
Yeah. So
fantastic driver.
I don't know what's coming next. And, if I go back 10, 15 years ago, even if I just look at would people believe that we would have home consumer products running at over a gigahertz frequency?
Yeah.
No
exactly.
way.
Yep.
Right?
Yep. And that's not that long ago.
No.
That's right.
So, if you ask me what's going to come along in 5 years, I have no idea.
Right.
Maybe I might have a little idea in a year or something. Within a year time frame, maybe.
Right. But
5 years from now, I have no idea. Somebody will come up with something completely new. People, will innovate, and that's mankind.
Yeah.
And in electronics,
although,
and then
are we reaching the upper limit of practical electronics as we know it in terms of high frequency stuff?
Well, that's
are we currently pushing the boundaries?
That's a very interesting point. Something that I've thought about a lot. In that, for instance, I don't think you're going to see frequencies increase much from now on.
Right.
Functionality is going to get bigger and bigger, but you see what's happening. Frequencies haven't increed much in the last few years.
No, they haven't. It's all going parallel processing, for example.
That's correct.
Yeah.
They've got more functionality by paralleling multi-chip, computers, things like that.
Mm-hmm.
Yeah.
So I think technology will continuously innovate, but in different ways.
Right.
So, there for many years, we said every year the frequency is going to double,
Right, yeah. And that stopped 10 years ago, didn't it?
Yeah. You know why? Basically, we've come to the limit of using standard epoxy glass printed circuit boards.
Yeah.
Above a gigahertz, that's a lousy dielectric.
Yeah. So
can
just a
you
cost?
see any change in the way we interconnect circuits and parts?
Well, everybody keeps on talking about optical,
Right.
but I haven't seen
everything going optical. Well,
yeah, on the board level,
right.
everything optical. I don't know. Maybe.
FR4 is too easy. It's just too practical at the moment. It's just solves so many issues, whereas optical seems very difficult.
It feels like to me that a lot of stuff too is just it's all moving down onto silicon. Like so they're either pushing it all into multi-chip modules, like silicon on module or whatever,
hybrid modules and flip chips,
or even just all onto the same die.
Well, larger and larger scale integration is what we're going to see. I think. Well, that's where it's been going. It's all going down on the silicon,
and we're going to need more people like you because we're pushing the boundaries even further.
The noise and the EMC issues are not going to go away. The regulations are not going to go away.
Yep.
So somebody's got to do something about that.
Yeah. Well, I think I've read the noise reduction techniques one. I think I definitely need to run out and get the newest one though. The magnetic.
I think you'll like it.
It's,
as I say, almost 900 pages.
Wow.
It's twice as long as the second edition. I mean, I have a whole chapter in there on PCB layout and stack up, just talking about different combinations of layers in different ways and the advantages and disadvantages.
Nice.
Well, we got about roughly 5,000 listeners, so hopefully you just sold another 5,000 copies with just that chapter.
Well, that's okay. It sounds good to me. That sounds good to me.
Yeah, all right.
I'll go for that.
Okay, good. Yeah, tell your publisher where you. It was the amp out.
No? We'll start another printing right now.
Yeah, right.
Yeah.
Right. Well, Henry, thank you so much for being on the show. We really do appreciate. Your experience is unbelievable, and I can't wait to read this third edition, the quote unquote third edition, but the newer book. I think it's gonna be really great.
Okay, well, I enjoyed doing it. I enjoyed talking about this stuff, and it's been almost an hour and a half. I wouldn't realize that time went flying like that. So time flies when you're having fun, I guess.
Yep.
And I've enjoyed your New Jersey accent.
Yes.
Oh well, it's probably different.
It's great. All right, well, thank you again.
Thank you very much,
Okay,
Henry.
guys.
It's been awesome.
Okay, bye.